Okay, good afternoon, all, and thanks for joining this session 5AW, zOS Container Extensions Part 3, zCX use cases and demo with Steve Warren. Steve, you want to be asked questions as you go, so yeah, please feel free to shout them out in the chat. I'll read them out as they come in. Over to you, Steve. You have the floor.
Thank you, Joe. Hey, everybody. Welcome back to part 3 of zCX use cases and demo. We've talked about several things related to zOS container extensions and in terms of an introduction to the topic and showing you how you can get started with provisioning a zCX server. And today we're going to be talking about some zCX use cases and hopefully have a live demo. Let me tell you just a little bit about myself in case you haven't heard me talk during the GSC this week. I work over across the pond in Poughkeepsie, New York in the US, and I focus there as a technology architect and helping clients adopt new technologies on zOS. And in particular, I've been spending a lot of time over the last couple of, I'd say, a year and a half or so, helping clients as they on-ramp using zCX. And we've had a lot of folks go through a workshop that I run. We'll talk a little bit more about that. It's a free workshop that we offer. But in essence, to get us on-ramped and do POCs or to actually put into production zCX. So the purpose of today's session, as I move on to the next slide, is just to give a little bit of an overview in case you missed parts 1 or part 2 about what zCX is, and then dive right into potential use cases that we've seen clients embrace and that maybe would be a compelling reason to implement this technology at your enterprise. Okay, so that's kind of where we're going today, and hopefully you'll get a lot out of this particular session. Again, having a good dialogue is only going to be to your advantage. There is no dumb question. All this stuff was foreign to me a couple of years ago. I didn't know anything about zCX. I could barely even spell it. And now, I mean, only through using it and telling other folks about it have I gained the skill. So no matter what your question, however basic you think it may be, feel free to ask. You can also on the title page of this presentation, I provide my email. I would highly encourage you to leverage that as well if you have any additional questions beyond today. So with that, this is kind of where we're going to go. Let's get started. So again, just a quick overview. And again, the focus of zCX is to add a whole new ecosystem of software that runs on zOS. And we talked about in the intro session in part 1 last week, we talked a little bit about that, years ago. I mean, you had COBOL PL1 assembler application deployed, either ran as a batch job or it would be deployed in middleware applications. And that was the scope of the zOS software ecosystem, And then, of course, a number of years ago, we introduced something called Unix System Services, which really transformed the types of work that can run on zOS. And at first, it was programs that were written that were Unix compliant, probably in C or C++ on another platform, but again, Unix compliant applications, you could take them over to zOS, recompile them, and they would run. And then by allowing that environment of a Unix compliant applications, we then were able to deploy things such as having a state-of-the-art JVM that runs on zOS today, supporting Java workloads, and of course, on top of that, supporting Python and all the other newer programming languages. Of course, supporting things like WebSphere, being able to serve applications, web applications as they're being directed to zOS, and the whole ecosystem that goes along with WebSphere. And then we have a couple other things. We have the zOSMF, a more modern browser-based way of managing your zOS. We have things such as Apache Spark, which and other AI packages that have been ported to zOS that run directly on zOS. And then finally, we have Zoe, again, another way of being able for application programmers to be engaged. All those things facilitated by Unix system services. So what we're talking about here, again, with zCX is another whole set of applications now that can run directly on zOS. And these are going to be Linux on Z software that it already runs. The binaries already can run on a Linux on Z partition, or Linux on Z on top of KVM, Linux on Z on top of VM. Those applications that are packaged as Docker containers, they can run directly side by side with your zOS traditional applications or your Unix system service applications. And so this is really the next evolution in the types of applications that can run on zOS. And so the purpose of today is going to be focusing on what use cases do we have that we can illustrate how this makes sense to run in this these type of applications on zOS. So again, this function is a new function on zOS 2.4. And again, it's the Linux on Z binaries. And the key operative phrase is the last part of bullet number 1 here, in direct support of zOS workloads. This is the sweet spot of zCX, and you're going to see all of our use cases are going to be focusing on this particular use case. It's when we have direct support of workloads that already run on zOS. There's interaction with a Linux component, and we'll see all the different ways that manifests itself in just a few moments. But that is where the benefit of zCX comes into play. And we'll see in another slide also coming up of where maybe it doesn't make sense to deploy on zCX. Okay, so again, you don't need to provision a separate Linux server whenever you deploy a Linux application that's interacting with a zOS application. I can actually run that container directly in a zCX server, which is a started task running on zOS, and it can just run side by side. And why would I want to do that? Well, you have significantly improving your network transaction rates and greatly reducing the latency between your Linux application and your zOS application. So this is one of the main benefits of zCX is to improve this latency and to improve the speed in which your Linux application and your zOS application can be talking. Now, if you're running an extremely low amount of work and you don't have performance requirements, latency maybe is not as big a deal. But when in today's workloads, when you're running lots and lots of applications and lots of instances of transactions all at the same time, and you have SLAs that are governing how fast those operations need to occur, this is a very significant point. And you're going to see from slides coming up, again, giving you a preview, that the total cost of ownership of deploying on zCX in many cases is significantly less than running on, for example, an x86 platform. And so we'll show a little bit more about that in just a few moments. The other big benefit of running on zCX is you maintain the overall operational control of your Linux app within the zOS framework. So if I have an application that is leveraging zOS, maybe because zOS is the system of record and it needs to get the data that's over there, you have an insistent system of engagement, which maybe is on Linux, a system of record, which is on zOS. I want to be able to leverage and be able to control and manage both parts of that application without having to coordinate with some other zOS, non-zOS sysprog, for example, to govern when I have a planned outage. How is that Linux application going to interact when I move that application, for example? And what about the zOS quality of service, which are second to none, right? Using zCX, I can transparently exploit the zOS qualities of service by having my Linux application running in zCX the underlying technologies that zCX uses can just be transparently acquired by that application without the application even knowing is on Z. So this is, again, what we were talking about. Okay, that's about all we're going to talk about for this slide. We have maybe 2 more overview slides that we go a little more detail, focusing on use cases before we continue on to the meats of this presentation. Okay, so first of all, if I want to get involved and experiment with zCX, what are my options? Well, of course, there are a number of ways you can do this. The option that a lot of folks have utilized is if they don't have a hardware feature code, which is normally required, or this new software monthly licensing charge option, you can just use the trial. So there's 90 days that you don't have to purchase anything, and you can actually try out and zCX for yourself and kick the tires. Now, when the 90-day period ends, it is a hard 90 days. And once that 90 days has expired, zCX instances will no longer work unless you have either the one-time charge of a hardware feature code, which applies to a particular CAC, or you have this new thing called the Container Hosting Foundation for zOS enablement. So when you have this optional feature installed, which incurs a monthly licensing charge with it, you can enable as many LPARs on a single CAC or CPC as you want for no additional fee. So you're going to be paying either the one-time fee for the hardware feature code, or you pay a monthly licensing fee for the Container Hosting Foundation for zOS. And then that will enable as many LPARs on a single CPC to leverage zCX, and as many instances of zCX on each one of those LPARs. Okay, so just remember, you need 2.4 and you need at least a Z14 or Z15 required. Okay, so probably the last overview slide we're going to talk about is just, again, level setting everyone about what zCX provides here. So zCX is a turnkey virtual Docker server software appliance. And what do we mean by all of that? So what we mean by that is that IBM provides a turnkey solution for you that has all the software you need to deploy Linux on Z Docker containers almost instantaneously from the time you provision this particular server. So what that means is that IBM procures the Linux kernel, it procures the Docker engine, it procures several other things that you're going to need in order to be able to run your Docker workloads inside of this address space. So you don't have to procure that stuff. You don't have to actually go out and get maintenance. IBM on regular cadences provides that maintenance to you of the pieces of that appliance, as well as, of course, fixes and enhancements as well, in addition to the scheduled maintenance. So how you stand that up, again, we've learned in part 2, you use zOSMF workflows, and we actually did a live demo of that where we actually provisioned it in real time with no speeding up of a clock to show you how fast it takes you to deploy zCX. Okay. And once you have deployed that zCX, I can then go on to my favorite SSH client, and from a command line. So it could be from PuTTY, it could be from Terminal and Apple, it could be from PowerShell and Windows. You can just go in and SSH into that zCX, specifying the dynamic virtual IP address associated with this zCX address space, and the correct port, of course, and you are now at a Docker command line. And now from that Docker command line, I can actually do any Docker command to install applications, to pull images from a repository, to start and stop containers, to create all the constructs of Docker. And what we were saying with this is, in terms of the technology, when I'm communicating between my zOS address space and my zCX turnkey appliance, I'm leveraging this high-speed cross-memory virtual network, which is called same-host. And same-host technology is a memory move to move data across TCP/IP. There is no shared memory in this. There's no way the Linux application doesn't even know it's running on zOS, but this high-speed network allows any networking flows it needs to make to go over the absolute fastest possible connection, bypassing layers of the TCP/IP stack, as well as not going in on any networking card, for example, and all being close to 100% zip eligible. And so this is really, really cool technology that we have here. And so now, once we've done that, now let's talk about the qualities of service again. We get these in qualities of service automatically brought forward. We have storage resilience. The backing of this zCX appliance in terms of Linux disks is actually vSAM linear data sets. The application doesn't know it's running on zOS or it's using vSAM linear data sets, but through the VirtIO devices that are provided by zCX, we're able to transparently write to linear vSAM data sets. And as a result, we're able to take advantage of all of the features that vSAM linear data sets have, such as hyperswap and hyperlink and pervasive encryption, and the list goes on and on. All the things that you normally take advantage of. In terms of disaster recovery, again, we don't need to coordinate with non-zOS admins when planning a maintenance window or moving workloads or even a disaster recovery solution. We can use common constructs like GDPS to move our Linux workload over to another system in a dynamic fashion. In terms of networking, we have support for DVIPAs, allowing us to have non-disruptive changes when we need to move a zCX software appliance from one system in the Sysplex to another. We can do that with minimal disruption and have a dynamic movement of the workload. And of course, we already talked about the same host technology. And then, of course, we know that Workload Manager can control the priority of the workload that runs in a particular zCX instance. And it has all the normal constructs in terms of reporting and the ability to add capacity on the fly. So just some of the qualities of service that are provided. All right, so now let's deal a little bit more with use cases. We're going to hit these points. This is an overview of the use cases. We're then going to go into much more detail about each one of these particular aspects of the use cases. So the first one we talked about in the opening slides was expanding the zOS software ecosystem for zOS applications. There's a whole new set of applications that can run. And the idea here is that we can now exploit microservices, and so we can expose zOS data and transactions, or exploiting directly from zOS and invoking a microservice from zOS. So we have a couple different options. Either the Linux application can be driving zOS through like a system of engagement versus system of record type of model, or we can even have zOS applications going the other way and leveraging a microservice which is available, for example, only on Linux. And so we're able to now run that directly in another address space right alongside that zOS workload. And so we gave some examples here of some of the applications you can do in that space. We have like non-SQL databases that are not normally supported on zOS, like MongoDB is a good example. Now suddenly you can run that on zOS. Analytics frameworks. We talked about Spark before, but there's a lot of analytics frameworks that are not ported to zOS. I can leverage all of those, and I can leverage those in a way that allows me to do them in a transactional nature. I can do what's called transactional AI, because I can still meet SLAs because I'm now leveraging an analytics framework which has such a low latency that it actually is practical to run inside of a transaction. So now we can throw out these rules-based, quote unquote, AI workloads and instead do a true deep learning AI framework, analytics framework that is leveraging technology that runs directly in zCX. There's messaging frameworks, and we'll talk about quite a few of these. The Apache Kafka, MQ Client Concentrator, and Aspera. We'll talk about how these running on zCX can provide additional capability or reduce cost or increase speed with your applications. We have App Connect Enterprise, marrying applications together, and we'll talk more about that. In fact, we're going to actually have a demo that leverages a couple of these that we've just talked about here in just a moment. Web server proxies and even emerging programming languages and environments. What happens if you have a piece of code that is written in a language that currently is not natively supported on zOS, but it is supported on Linux? Guess what? I can run that application on zOS. What happens if I have certain programmers at my shop that have a set of skills that have programming languages and environments that are not native to zOS? Again, I can leverage this environment because with a Docker container, a Docker image, I can embed programming languages in as part of the container. And by default, when that container runs, that programming language is available to the application running inside. So lots of cool things about expanding the zOS software ecosystem. There's also an aspect of systems management components and the fact that there are many applications that we have in our ecosystem that are necessary to support the zOS environment, but they actually don't run on the zOS environment. And this is a pain, and we're going to talk about Service Management Unite in just a few moments, that this idea is that I have to provision a separate Linux server that I have to maybe talk to another organization to actually stand up an LPAR, stand up a Linux server that can do things that I need to do in support of zOS. And last but not least, open source application development utilities that before, again, I had to provision on some other server. I can now provision directly on zOS. And why would I want to do that? Well, because again, the same type of things that we talked about just for the system management components, that I may wish to have my zOS applications that run on zOS also have my DevOps pipeline run on the same platform. Okay, so let's talk a little bit about this slide here. So before we get too carried away here, are there any questions so far that you guys may have to ask? Whoop, and my apologies here. I'm trying to move something here on my screen. Any questions? Okay. So before we get on too far, let's talk about what zCX is not a replacement for. So there are, just because an application can run on Linux on Z doesn't mean that I automatically am going to run it in zCX. Remember the operative word on that, I think the second slide on this entire pitch that I've been talking about, it said indirect support of zOS workloads. So if I have native Linux on zLPARs or Linux under ZVM or Linux under KVM or Linux One offerings or even HyperProtect services, if I have no interaction with zOS, and you can think of Linux as the endpoint, I have an end user and they're talking to a Linux application and it never touches zOS. In this case, it may not be the most efficient use of resources to deploy on zCX. You certainly could, and if you have only one Linux application that you're running, maybe, and you don't want to have another Linux LPAR, you certainly can stand up zCX to be able to run those workloads. But in some cases, those workloads would be better suited in a pure Linux environment, because again, without the zOS workload interaction with your Linux environment, sometimes it may make more sense to deploy it directly on Linux. And so some of those environments listed on the left may apply. We also have the idea of native zOS environment software. So applications that currently run in zOS Unix system services or zOS Unix, in many cases are going to run in the fastest way when you're running just native on the operating system, right? And so if I have Java or likewise Java or Python applications Java is the JVM on zOS is really good. And the Python based on top of that, also there's several offerings for Python that you can run natively on zOS. In many cases, it doesn't necessarily make sense to deploy a zCX and add another layer of an application when you don't need to, when you can just run it directly on zOS. And so there is a case for running things natively if you can run them natively on zOS. And of course, Java, write once, run anywhere type of mentality it fits into that play where it might make sense to run it natively for the best possible performance. And then running software natively on zOS. There are some packages, and I'll give an example of IBM WebSphere. So you can deploy WebSphere Liberty inside of zCX. But when you do that, you're going to lose some of the WebSphere for zOS tight integration that it has with the operating system. Things like tight RACF integration, tight WLM integration, and some of these other things that you're not going to get quite that same tight integration running it in zCX as you would if the software was running natively on zOS. So there are use cases where, again, you already have an application that runs natively on zOS, and it's already optimal. It's not necessary to move that application into zCX. Because by doing so, you're creating another layer of what that application is running in, as opposed to just running it natively on zOS. So again, applications running native on Linux that have no endpoint or no direct interaction with zOS workloads, as well as applications that already run natively and already run very well, those may not be the best candidates to move into zCX. So again, what are good candidates? It's kind of a reiteration in a different way of looking at it from the previous slide we talked about. So we want to, in this case, we want to increase our zOS software expansion. There might the use case for that. In this case, we want to have to transparently inherit zOS quality of service. The thing doesn't run on Linux today. It doesn't run on zOS today, and we want to inherit the zOS qualities of service for our Linux application. So when we do that, and we want to have operational control for that application, and it of course interacts with zOS, we're going to get a tremendous benefit from that low latency, high bandwidth, high throughput connection that the same host connection provides between zCX and native zOS applications. And yet, at the same time, having operational model control and transparently inheriting qualities of service. So again, co-locating non-SQL databases, the latest microservice analytics frameworks within native zOS without compromising. Again, that systems management, less burden on operations and dependency management. So what we're talking about here is that now I can have applications that are managing zOS can actually be hosted on zOS as well. And I don't need to involve other folks from other divisions or other places for them to stand up a separately provisioned Linux server. Likewise for DevOps, same thing. Don't need to stand up a Linux server for deploying our DevOps pipeline using the latest open source technologies for DevOps, whether it's GitHub or Jenkins or Maven or some of these DevOps technologies can run now directly on zOS. All right, so with that, we're now going to dive into some individual use cases here and talking about some of them and why it makes sense. And then we're actually going to show a demo and then talk about a few more use cases. So the first one we're going to talk about is running Kafka. Kafka is one of the most popular pieces of open source software that is out there in the world today. You can see that there are hundreds of thousands of clients. Yes, that's right. There are hundreds of thousands of clients out there that run Kafka as a messaging framework in their enterprise, right? So if I run Kafka without zCX, and for example, let's just say in this example, I have a zOS application that wants to write a message to a Kafka topic, right? In the upper right-hand corner, we see a zOS Kafka producer, an application it wants to write out there. If it writes out to x86 Docker, it has to go through a high latency, maybe low bandwidth connection to Kafka. I also don't have operational control, and I'm not leveraging zOS qualities of service when I run that Kafka. So as soon as that application now is going off to Kafka, now I'm having a step down in availability, a step down in just performance, because I'm not going to be leveraging this ultra high speed connection that I have if Kafka is like on the bottom where it's hosted in zCX. In this case, I'm producing a message out to Kafka. My Kafka consumers now, there's only one external network jump that's being made, and that is the Kafka consumers talking to zCX. And if you're implementing IWQ, which is called inbound work queuing, which is a function available on zCX on an OSA Express card, all of these TCP/IP interactions with Docker are actually going to be dispatched onto zip engines. So it's not like with this bottom solution that I'm going to be incurring a higher monthly licensing charges. It should be close to zero, but at the same time, I'm gaining better performance. I'm gaining operational control over that Kafka workflow, and I'm able to have zOS qualities of service, including things such as the priority of the workload running, for example, in Kafka. So just one example, this is a popular use case. We have lots of clients that are saying, I want to run with Kafka. You'll see, I'm going to talk about a red book that highlights some use cases, and Kafka is chapter 1 in that book in terms of how do I implement Kafka in zCX. We also have something called the MQ concentrator. So let's just talk about the MQ concentrator for just a little bit. And what the benefits of running this MQ client concentrator and zOS container extensions. So the MQ client applications may connect and disconnect from MQ on zOS on a regular basis. And this has the potential of driving large amounts of CPU usage by the MQ channel initiator. So if you guys know anything about MQ, a particularly expensive operation is this initial connect to the queue manager. It's called MQCon, which will usually involve some things like a TLS handshake. The queue manager is going to perform additional security checks, and there's a whole bunch of other stuff that goes on every time a client tries to connect using these server con channels. So by using a client concentrator, the client connections are made to a proxy. It's a distributed queue manager. That proxy then routes the messages to one or more zOS queue managers over sender and receiver channels, which are normally long-lived connections and therefore typically much cheaper than using server con channels. And so this model, in some cases, can significantly lower the CPU overhead of zOS MQ. Okay, so let's just take a little more dive into how this would actually look like. Excuse me. So this is that example here we have on that we just talked about. Poorly written, or to put it a different way, non-optimized applications will do an MQ con, an MQ get, an MQ put, an MQ get, and then an MQ disconnect. So if they do an MQ con and disconnect surrounding every put and get that they have, which a lot of applications which are not really thinking of how to be optimized are doing, that MQ con is going to incur zOS CPU cycles, which is going to drive up your MLC costs for every single connection. So you're paying a CPU penalty for every single time the MQ con is being done. So if I were to put a client concentrator on a distributed server, for example, now those poorly written applications are still doing that MQ con and disconnect, but they're doing it on a server where you're not really worried about MLC costs of zOS. And so again, you're going to incur different you're going to be you're going to be having a reduced CPU for zOS, but there is additional latency added by having these two external network hops in this model. First, I have the network hop between the client application and the distributed server, and then I have a network hop between the distributed server and zOS. So you are having increased latency here. Well, what about if I were to do that and put that client concentrator layer, a concentrator layer on zCX itself? Well, with the concentrator hosted in zCX, the additional latency of that second hop is greatly reduced by leveraging the ultra high speed memory to memory same host network. And you have lower zOS CPU costs, much lower latency than running the concentrator on another platform. Now, of course, there are other considerations other than just CPU usage to consider before deploying the MQ concentrator model. So analysis really needs to be done by your folks at your shop. This has a little more added layer of complexity. There's a slight increase in latency because I do have these two hops. One is not an external hop, but it still is a hop. And of course, there are high availability issues at play here as well. But again, the MQ concentrator hosted in zCX may be the answer your shop needs for reduced MQ CPU costs. And so this is another use case using putting the MQ client concentrator hosted on zCX. So another use case is running something called App Connect Enterprise, or ACE, on zCX. ACE is an application that allows you to create message flows that enable you to connect disparate applications together. Applications that normally don't talk to one another, that normally have different message formats, for example, can be joined together through something called App Connect Enterprise. And like the name suggests, it connects applications together. And so this technology is really cool because ACE can now, the integration server for ACE, and we're going to be showing you a little bit more about this in just a moment. I can write a message flow without having to write a single line of code. I can write a message flow that connects application A to application B together and host the integration server directly on zCX to provide this ultra high throughput and ultra low latency between different parts of my application. We have, I don't know how many people I've talked to so far about their excitement about hosting ACE on zCX and not having to put that on a separate Linux server and having multiple external network flows when they're trying to connect application A to application B. And so we're gonna dive into this one a little bit more now. So I have a demo example that we're going to try to do live. Whenever you do a live demo, of course, there's always a risk that something will go wrong, but I'm hoping that you'll see the value here of running and getting a little hands-on experience of what it means to have this application. So in this example, I'm having a Kix web app that's running on zOS, and this Kix order is going to produce an HTTP message with an XML payload, which we want to deliver into Kafka, but we want to deliver that into Kafka in JSON format. And so we want to use ACE to transform this data from XML into JSON to remove extraneous fields that the Kafka consumer doesn't care about, that Kix is putting in the XML, and then to produce a Kafka message. And so using ACE message flows, I'm able to create this simple message flow which takes input from Kix through this high-speed network call from Kix down to ACE, and then ACE is going to running on zCX is eventually going to issue a Kafka producer. Is going to be a Kafka producer and put a message on a Kafka topic, and that Kafka can also reside on zCX. So before, where I maybe had two network flows, external network flows to get the application data from Kix to Kafka, I now have 0 external network flows in this example, both of these applications being hosted on zCX. So how would I actually accomplish something like this? So we're just going to take a little bit of a lower level view of this one scenario just to show you how you would actually make this happen. So first, let's talk about the Kix web application that's on zOS. Okay, so we're using in this example the Kix sample program called eGUI, which is shipped by Kix. And again, this eGUI application is based on a business scenario of an office supplies application. So it's a very simple application. Kix provides it as a good way of illustrating a lot of features in Kix. So in conjunction with this application, we've also implemented an interception routine built with Kix business events function. And so what that allows me to do is I don't have to modify the eGUI application in any way. Instead, I have created an event that's been deployed that will note when the in-stock value goes to less than 50 for a particular item in our office supplies catalog, and will generate a notification. So if any item in my office supplies goes below 50, it's the Kix business event that I have deployed is going to automatically generate an HTTP message with data in the XML format. And this is the trigger to have the data flow into ACE. So this is how we have our Kix application. Again, an unmodified Kix application with Kix business events that will send this trigger message to ACE. Then I have ACE. So I deploy ACE on zCX. So I'm going to do a Docker build to actually build the image that I have. And there's instructions out there from the App Connect Enterprise website that you can easily create this image in just literally about 10 minutes worth of effort. You can have an image built for ACE on zCX. And of course, an image is not a running instance of an application. It's just a static copy of a piece of software. And so I'm going to use a Docker run command to start that image that I've created to start running this ACE integration server on zCX. And the ACE integration server is going to allow us to host these ACE message flows that I'm going to be creating. And the way I create an ACE message flow that without having to write a single line of programming to actually transform the data that's from XML that Kix has generated into this JSON data that has extraneous fields removed is to use this Eclipse-based ACE toolkit. And it's going to create this message flow, and it's going to take the input from the Kix generate XML. It's going to transfer it to JSON, delete the extraneous fields not needed by the Kafka consumers, and then it's going to feed that Kafka data stream and put it in a topic in Kafka that's also running, in this case, in zCX with the altered content. And then it's going to reply to that Kix HTTP request to say, hey, 200 HTTP return code, everything works successfully, or some kind of a failure. And again, we're going to deploy this application that we create in the Eclipse-based ACE toolkit to the ACE application that we just deployed using Docker running in zCX. And then the last piece of this application is simply a Kafka topic running in zCX. So I'm going to deploy Kafka in zCX. So the Kafka image can be securely obtained from something that we haven't talked about yet called the IBM Z and Linux One container registry. We'll talk about that more. The bottom line is there's a place out there you can just go grab this image securely and actually start that application with a Docker run command. And so now I have Kafka running, and the last step I have to do to make all this work is to simply do a standard procedure to create a Kafka topic in that is kind of like it's kind of like a queue that I can put messages to and take messages off. Okay. And so by creating that topic, I can produce a Kafka message to it, and that Kafka consumer can go ahead and retrieve any messages that are on that topic. So these are all the steps that I really had to do. And so now we're actually going to go into the demo. And so I'm going to basically kill this here right now, and we're going to look at a couple things here. So the first thing I'm going to do is, here is my Kix eGUI application that I have enabled here. And you will see here that there's a lot of items that I can order here. And we're going to just pick one when we actually run this demo for sure. And just to show you, we're going to go into something called Portainer. Portainer is an alternative to the command line interface that Docker provides, and I can actually visualize things that are running on my system through this GUI web-based interface. And so this is really cool. So I'm in the container section right now, and you can see I have Kafka running on one of my zCX servers here. And we're going to actually be leveraging that in just a moment to be able to actually see what's inside of the Kafka topic currently. And then last, I have another zCX server that I'm running that actually has my ACE server running. And what's cool in Portainer is I can actually click on one of the published ports. In this case, I happen to know what these 3 published ports are. This is the way that Kix is going to be communicating to me if they're using HTTP. This is the port that they're going to be using if they want to communicate via HTTPS to the integration server. And this is the administration port. And so if I click on this administration port, it actually launches App Connect Enterprise. This is actually running in zCX right now. And I have my my administration panel for ACE. And so you can see I have a couple applications that I have, Kix to Kafka and Test Kafka applications that I have deployed here on my zCX instance running on in the ACE integration server that is running on zCX. Okay, so what we're going to do right now is we're going to go over to Kafka, and to show you that this is a way in Kafka, I can actually go inside of the container and issue commands against the container. So I'm just going to log in here. And hopefully this will work. Okay, yeah. Okay, so I'm going to go in here to the command line interface, and I'm actually going to go to the command line for Kafka. So I'm actually at the Kafka command line. So I'm actually inside the container, and I'm going to direct a particular command to that container to show what's currently in the topic that we're about to write a message to. And just to show you, I just did this prior to this. So you're going to see that there are things that are already in there for this particular example. So I'm running this particular example, and you can see that right now there are a couple items in here that are written in JSON format. This is all data that was taken from Kix. And right now you can see that there are 29 items available for item number 2 in there. We're going to show you when I run this example that will be updated, and this will have a new line in just a moment. So this is currently showing inside of Kafka the things that are currently inside of the Kafka topic right now. So now what we're going to do now is I'm going to go over to my Kix application. We're going to select item number 2. Notice there's 29 items that are left there. We're going to actually order one more of them right now. So I'm actually going to go in here and select this item, and I'm going to say, hopefully this will work. Okay, good. So I'm going to say, okay, it's Steve that's ordering an item, and department is ABC123. What this is saying is, Kix, I want to order one item of item number 2. There was less than 50 of those items. So remember what the rule is for the Kix business events is that when there's less than 50 items, it's going to generate a message to Kafka that basically says, I need a reorder of this. We're getting low on stock of this particular item. This is some kind of ballpoint pens that we're ordering. So I click on submit. It basically places the order. And what that order actually did was Kix business events noticed that this was below 50. It issued an HTTP request with an XML payload to ACE. ACE is going to transform that data into JSON. It's going to then remove fields that it doesn't need to have, and it's going to write a message to Kafka, and then it's going to issue an HTTP 200 return code that's back to Kix that says that it worked. Now, how do I prove that? Well, I can go back here and you notice that there's a new message here that was written here, and notice that the stock level is no longer 29, it's 28. So what we did is we ordered one item, and so now the stock level is only 28, and the information that we had for this particular application has now been transformed into JSON. And remember, all of this applications, this Kafka is running on zCX, on zOS. The ACE application that we showed over here on the, whoa, let me see if I can fight with this a little bit here. The ACE application is also running on zCX. So this is just leveraging where you'd have normally 2 external flows. I have zero network flow, external network flows. Everything is running inside of zOS. So just a really primitive example. We demoed this to clients, and the clients were doing pretty much, they said, this use case is exactly what we're doing. And right now we were concerned with both the management of this, that we have all these applications on different platforms, and we have to maintain this for planned outages. It's complicated to manage. We can't control the priority of the workload that's running in here, and the network latency is an issue as well. And so with this, now everything is running on zCX. Okay, so I'm going to go back to my presentation here, and we're going to resume where we left off. Hopefully it'll show up. Okay, good. Any questions out there before we move on to the next use case? We have about 8 minutes left, and I think we're going to be pretty much right on time here. Okay. All right. So one of the use cases we mentioned before was Service Management Unite, and Service Management Unite gives you the ability to use this browser-based interface for zOS management, and it's very powerful. It has integration with NetView, it has integration with system automation, and integration with Omegamon. And so with this view, I'm able to have a really nice, I'll show you a screenshot of what it looks like a little bit. But again, I don't need to deploy with, if I implement this model in zCX, a separate Linux server. And so this is really cool technology. So again, from a web browser, I can now monitor multiple LPARs and have a lot of the capabilities of Omegamon, NetView, and system automation all through the SMU automation dashboards. And so it's very powerful function. You get something that looks like this. As you can see, again, this is running on my zCX right now. I have Service Management Unite with all these panels where I can do administration of zOS and monitoring of zOS through this powerful set of functionality. So again, another use case for zCX. There's another advantage you can leverage with zCX and MQ, and that is running IBM Aspera Fast.io gateway on zCX, and how this can really enhance performance. The IBM Aspera Fast.io gateway is really a bidirectional and multi-session data transport technology. And in some cases, it can significantly increase network throughput and provide more efficient data streaming, and with less chargeable CPU utilization. So again, the zCX container is going to co-locate this with zCX with the Fast.io functionality gateway to allow for a more concise architecture and more continuous availability to IBM Aspera, and decreased burden on dependency management. So if we just look at this a little bit more, in essence, this Aspera Fast.io gateway is a fast TCP/IP tunnel that can significantly increase network throughput for high latency networks in particular. And again, today it's used to speed up connections between queue managers in different data centers. But by running Aspera Fast.io and zCX, there is a very low latency between the MQ channel initiator and the gateway. And so this example I show you right here, you have a requester and responder. This is like a bidirectional workload configuration. It uses a pair of these server channels. And the fast.io gateway uses a proprietary user-defined protocol, or UDP, which sends the data, and at certain points it can provide scrutiny on that received data. And if there's, in the event that there is lost data, it requests the data to be resent. So again, for higher latency connections, this fast.io throughput is significantly faster than without. And again, it's all dispatched on zips. There is a great white paper done by the IT Economics Consulting and Research team back in February of this year, 2021. And they did a side-by-side comparison running a simulated banking application using two environments. They have a Z-based solution using zCX connecting to a zOS DB2 versus an x86 communicating with zOS DB2. And there's a link to the study here. I'm not going to talk too much about it, but this is kind of the way that they did their test. They put a load generator of a lot of different requests using analogous applications. Some of those applications were running on Docker, running Docker containers leveraged on x86, and we had others where Docker containers were leveraged on zCX. And they have a whole analysis. And of course, the back end of the data is still zOS. So in the case of the x86, they had to do an SSL connection to connect to the banking database cross-platform, right? So they have some pretty amazing numbers, and I'll let you look at the report for more details. But the zCX provided an 8x core reduction over x86. So there's not always a one-to-one mapping. In fact, there's definitely not a one-to-one mapping when you're talking about the number of cores you need for zCX versus the amount of cores you need for x86. They also found that there was the TCO was 43 and sometimes over 50% lower total cost of ownership than x86. And they figured in every single aspect in terms of energy, space, networking, software, hardware, database, and even disaster recovery costs associated with that. And then as zCX also provide 115% greater throughput per core. And so you can see that there was significant throughput benefits across the board. It's the amount of throughput, of course, using that low latency, high throughput connection of zCX same host is really going to drive those numbers up tremendously. The last thing I'm going to talk about today with the remaining couple minutes is just talking about the IBM Z and Linux One container registry. So a lot of clients have come to us and said, you know, it's really great that you provide, Docker containers, but he says, my company will not allow me to download and pull an image from Docker Hub, for example. It's not secure. This has not come from a trusted channel. How do I know that people have not inserted other software into that? And how can I make sure I can download that securely? And so IBM has provided a set of vetted images out there in the IBM Z and Linux One container. And you can basically click on the icon here in the presentation here and to get started to get your own Linux One container registry. And there's step-by-step directions about exactly what to do there. So again, it's on a trusted channel. IBM's built these from source. So you have no unintended binary payloads inside of these standard applications. You can request for other applications that aren't out there right now to be put in there. Images are scanned for known vulnerabilities, and even a report is provided to tell you what they found. And then to make sure you're securely pulling those images, they have hashes that are there. And best of all, there's no cost to you. So just to give you an idea of some of the images that are out there, a lot of the standardized applications that run a lot of applications that run in the Linux on Z space are available out there. And again, these are vetted images that clients can be assured that this is IBM content that IBM has built. And so we'd encourage you to check out this website. This answers a lot of questions, and solves a lot of problems for companies that want to run this, but would not be allowed to run on zOS unless that they had some type of vetting for this set of applications. And so we'd encourage you to check out this container registry. And with that, I'm just going to end that we offer a free workshop in IBM. So our IBM Garage for Systems, which was recently renamed the IBM Systems Elite Team, we provide a free workshop that you can leverage that can allow you to just get a more detailed, customized experience for you. Again, no charge to you whatsoever. I would encourage you to take us up on potentially taking that workshop. It's like it can be up to like 12 to 15 hours worth of a way of how to onboard on the zCX. A lot of folks have used this as a springboard into a POC that they want to run for zCX technology. I'd also highly recommend this. There's 2 outstanding red books for zCX, and this one is really good in focusing on several of the technologies that we just focused on today, in terms of detailed explanations of how to actually leverage those use cases. So I would encourage you to take advantage of that. There's also a Getting Started publication that tells you all the basics about how to get started, as well as a bunch of Getting Started videos that we've provided as well. And with that, I want to thank you for your time. Are there any questions that you may wish to give to me? I would ask that you take a moment and please use your feedback to rate this session. The folks at GSE UK really take your comments really seriously and value your input.
Thank you very much. Have an excellent presentation. We wrap up the zOS container extension. So if anyone has any questions, please raise them in the chat box. Otherwise, we still have time, but I don't see any questions. Thank you very much. For everyone else, our next session will be tomorrow at 12 p.m. UK time, and the subject of that session will be understanding PalmLib for a successful IPL. So thank you very much, everyone. Thanks, Steve, once again. Enjoy your evening, and we'll talk tomorrow. Thank you.
Okay, thanks, everyone. Take care.